It's part 2. So we're looking at a couple more examples of using these formulas, and here comes the first one. I did put a little bit of stuff in here in advance to speed it up. So here we go. We're looking at finding the cosine of x minus y given information about sine of y, cosine of x. Well, the sine of y is 9/41. So I drew my right triangle for angle y, sine opposite over hypotenuse. Using Pythagorean theorem, the missing side is 40. And for y is between 0 and pi over 2, it's quadrant 1. For x, also quadrant 1, 0 to pi over 2. And the cosine is 3/5, which gives us the missing side of 4. I also wrote down the formula for cosine of x minus y. Notice that for a minus formula, for cosine, we get a plus sign. So all we need to do is get the values for all 4 of these pieces. Cosine of x given as 3/5. Cosine of y, well, I need the triangle here. The cosine of y, quadrant 1, so positive, 40 over 41. And then we're going to add to that the sine of x, which we have to go to the triangle for, 4/5, quadrant 1, so it's positive. And finally, the sine of y, which is given as 9 over 41. Looks like we're going to get this common denominator of 41 times 5, 205. And we get 120 plus 36, so 156. It's a big division sign, but there you go. Next problem. This time we're given x between pi and 3 pi over 2, that's quadrant 3. Y is between pi over 2 and pi, that's quadrant 2. Cosine, because we're in quadrant 3, the cosine is negative, and yes it is. And here's cosine labeled as 1/3. Now, I'm stating it's quadrant 3, so I'm not including the signs in my reference triangle. So I've got a cosine of 1/3. Pythagorean theorem gets me the missing side as the square root of 9 minus 1, the square root of 8, or if you prefer 2√2, and I prefer 2√2. Second triangle, the sine is 5/13, missing side is 12, and it's quadrant 2. We'll deal with those signs in just a minute. So here we go. We need the cosine of y triangle, 12/13, but in quadrant 2 cosines are negative, so negative 12/13. Cosine of x is given as negative 1/3 plus. Sine of y is given as 5/13. Sine of x, we're in the triangle 2√2 divided by 3, but in quadrant 3, that's negative. So negative 2√2 divided by 3. And as seems to happen every time, common denominator here, 39. I get negative 12, negative 1, so it's 12. Minus, looks like 10√2. And there's nothing we can do about that. We're done. That's our exact answer. Obviously, a calculator, we could play around with that. Now, that's it for the prepared slides. I'm going to show one last example, though. Maybe a bonus example. How's that? Bonus example. Yay. What if we wanted to find something like this? The sine of the inverse cosine of 1/4 plus the inverse sine of 2/3. And just to make things a little bit more interesting, let's take the inverse cosine of negative 1/4. How would you handle a problem like this? I'm going to give you a quick hint. Remember, inverse trig just give us angles. So this whole angle here, we could call it, say, alpha. This whole angle called inverse sine of 2/3, it's an angle. Let's call it beta. I'm going to go one step further. The inverse sine of a positive number is a quadrant 1 angle. And the inverse cosine of a negative, well, if you remember, for inverse cosine, you're going to be somewhere between 0 and pi. Positive, it's quadrant 1. Negative, quadrant 2. Alpha is a quadrant 2 angle. Hit pause. Try this problem and come back and see how I did it. Nay, wait, I said hit pause. All right, here we go. Solution. Sine of, I'm going to rewrite this, is just alpha plus beta identified here. And the formula for that is the sine of the first, cosine of the second, plus cosine of the first, sine of the second. So this is what we need to do. And just like in the previous problems, we're going to make some triangles. So here's a triangle for alpha. Because what this tells me is the inverse cosine of negative 1/4. That's what we're calling alpha. That's the angle. So the cosine of alpha is negative 1/4. That's exactly what this is telling me. And how do we label a cosine of alpha being negative 1/4? We put adjacent over hypotenuse. And the fact that it's negative, it's quadrant 2, so we know that. And just like the previous problems, missing side is going to be, in this case, 4 squared minus the 1, so this is the square root of 15. And if we look at the triangle for beta, the sine of beta is 2/3. So there's my 2/3. And the missing side then is the square root of 9, 3 squared minus 2 squared, so 9 minus 4, square root of 5. And this is a quadrant 1 angle. That should be all we need to get the answers here. So sine of alpha is root 15 over 4. Quadrant 2 signs are still positive. Cosine of beta, we're down here, adjacent root 5 over 3. Plus cosine of alpha, we're coming up to here again. Cosine is 1/4, but we already have the value. It's negative 1/4, quadrant 2. Finally, sine of beta, we're down here, and we already knew that, 2/3. Putting this together, common denominator looks like 12. Root 15 and root 5 is root 75, which actually we could simplify, and then minus 2. And if we wanted to play the game of simplifying, root 75 is root 25 times 3, so 5 root 3. So we get 5 root 3 minus 2, all over 12. Answer to this slightly more complicated looking problem. But there you go. And that's it. And go ahead, do all that work, submit it. I'll take a look. See you next week.